All right, areas of special quadrilaterals and triangles do the right thing. So the first thing we need to do is we need to have a definition of what area is. So area is two-dimensional measurement. Two-dimensional measurement. Usually we do our two-dimensional measurements in squares. So here's point A, and here's point B, and let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. That's a one-dimensional measurement. Distance, sometimes called length, is a one-dimensional measurement. If I'm measuring the distance, I'm not using squares to measure it, right? I'm just using one-dimensional units, right? The unit might be a centimeter, it might be an inch, it might be a mile, right? But it only has one dimensional, which is its length. So when I want to measure in 2 dimensions, then I'm going to measure in squares, for example. So if I put point C down here, then I can measure. That is a one-dimensional measurement as well. 1, 2, 3, 4, 5, 6. So that's 6 units, right? But then what am I going to do? I can turn that into a rectangle, which is a two-dimensional figure, and I can find the area of this two-dimensional figure by measuring squares, right? So this is a square. I could count all these squares. 1, 2, 3, 4, 5, 6, 7. No, I'm not going to count those squares. What am I going to do? I'm going to use a shortcut we call multiplication, right? And this is basically how we find the area of a rectangle, right? It's just multiplication. I say, well, if there's 11 squares this way, and I have 6 rows of those, then I'm going to have 66 squares, right? And I'm going to put that as square units. Okay. When we're measuring an area, it's very important that we use square units. Why? Because it's a two-dimensional measurement. You cannot measure a two-dimensional measurement in one-dimensional units. Now, what do I mean when I say do the right thing? I mean that our measurements must be perpendicular. Perpendicular, right? They must be at right angles. Well, with a rectangle, we always have a right angle because rectangle means right angle, right? So if I take one side times the other side, I'm going to get the area. You probably remember the formula something like this. Area equals base times height, or area equals length times width. With a rectangle, it doesn't really matter, right? Because you are always going to do the right thing because you have a right angle. And so all you have to do is take this is a one-dimensional measurement, times a perpendicular one-dimensional measurement will give you a two-dimensional measurement. Let's look at area of parallelograms. Looking parallelogram like the ones that you have on in your middle school, right? So this would be parallel to that, and this would be parallel to this. Definition of a parallelogram. Let's look at area of a parallelogram. Okay, somebody please tell me why I cannot just multiply this side times this side to get the area of a parallelogram. That would not be doing the right thing, right? When we find area, we have to have a perpendicular. We have to do the right thing. So you'll notice when you're taking a test and they give you a parallelogram, they'll usually give you a height, right? So they'll give you a little perpendicular and say, okay, here's the height of the parallelogram. What is height?
Is the perpendicular, right? That means perpendicular distance between parallel, that means parallel, sides. And I'm talking about quadrilaterals here. It's going to be a little different in a triangle. Okay? So it's the perpendicular distance between parallel sides.
Right? That is the perpendicular distance between these parallel sides. Now, why perpendicular distance? So we can do the right thing. If I wanted to count these squares, I would get frustrated because there's lots of partial squares in here. But let's reconstruct this parallelogram. Does everybody see this right triangle here? If I translate this right triangle over to here, right? Or if I took a pair of scissors and cut this off and pasted it over here, and that would give me a rectangle. Right? So the area of this parallelogram could be represented as the area of a rectangle. And what would be the what would be the dimensions of this rectangle? Well, the one side would be the height, and the other side would be the base. Remember, opposite sides of a parallelogram are congruent, so the opposite side would be the base. So the area of a parallelogram is simply the base times the height. Not surprisingly, the same formula as it is for a rectangle, since a rectangle is what? Simply a parallelogram.
And we could do that calculation quickly. Let's see, I think this was what, 16 units? And this is 1, 2, 3, 4, 5, 6, 7, 8 units. 1 dimension times 1 dimension gives me 2 dimensions. Area equals 16 times 8, which is 128 units squared.
Let me make one more note down here. Height must be perpendicular to the base, right? Height must be perpendicular to the base. So you can do the right thing. Area of triangles. Okay, and I'm going to start out with a right triangle. And the reason I'm going to start out with a right triangle is because it's easier to do the right thing. We already have our right angle. We have our perpendicular dimensions, right? Now, which one we call the base, which one we call the height, doesn't matter. I can call this one the height and this one the base. It doesn't matter either mathematically or definitionally. So when I have a right angle, the legs of my right triangle can become my height and my base. If I wanted to, I could construct a rectangle by simply reflecting the right triangle over the hypotenuse. So these two triangles are congruent, meaning that the area of my right triangle is simply half the area of this rectangle. The rectangle can be defined as the base times the height, right? Base times height, do the right thing. That's the area of this whole rectangle. But my triangle is 1/2 of that.
I could quickly calculate this if I know my base is 1, 2, 3, 4, 5 units, and I know my height is 1, 2, 3, 4, 5, 6 units. Okay, I can find 1/2 of 6 is 3, times 5 is 15 units, and of course those units must be squared. 1-dimensional unit times a 1-dimensional unit gives me a 2-dimensional unit.
Because maybe we have a triangle that does not have a right angle. Okay, and this appears to be an obtuse triangle. What are we to do? Well, because this is a coordinate plane, I can just draw it there. So we're going to call this the height. You might notice that breaks it up into 2 right triangles, so you could take those 2 right triangles and calculate something out, but I can do something even better than that. Turn this into a parallelogram. Let's see, so I'm going to make this we already know that this up here would be parallel to that, right? And then I used my slope to make these 2 parallel, and that gives me a parallelogram. I can prove that this triangle here is congruent to this triangle here.
This is congruent to itself by the reflexive property. This is congruent to this because opposite sides of a parallelogram are congruent. And this is congruent to this because opposite sides of a parallelogram are congruent to each other. And therefore I have side, 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 side. These 2 triangles are congruent.
What does that mean? I know I'm talking quickly, but that means that if I take the side perpendicular to my height and I call it my base, then to find the area of this parallelogram, I would simply do base times height. But because my triangle is 1/2 of that parallelogram, then my area of this triangle would be 1/2 of my base times height. Now I know what you're thinking, didn't we already do that up here? Well, we've just proven that this formula works not only for right triangles, but for any triangle whatsoever. Every triangle can be drawn as half of a parallelogram.
In this case, my area would be 1/2 of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 units, one-dimensional, times 1, 2, 3, 4, 5 units, one-dimensional. And that gives me
7.5, I think. Please forgive me if I made an arithmetic mistake. Trapezoids are special because they have only one pair, exactly one pair of parallel sides. So let's look at the area of a trapezoid. So by definition, we know that one pair of sides is parallel, the other are not. So there are no right angles here that were given to us, so we're going to find the perpendicular distance between the two sides and call that our height. Okay, just like we did for a parallelogram. So we did the right thing, right? And then this is our base. So we have our height and we have our base. Uh-oh, wait. Isn't this a base as well? And the answer is yes, that's a base as well. Let's call this base 1 and base 2. So now we have a problem. We have two bases. So what do? Well, the book gives us this formula. I don't particularly like this formula, and I'll tell you why later, but it says 1/2 of the height times B1 plus B2. The reason I don't like it is because it's not intuitive. Think about our mid-segments. Remember the mid-segment, right? So I'm going to take this point here and this point here and connect them. So if I take the average of the bases, that's going to be perpendicular with my height. And then if I make a rectangle out of that, I'm going to get equivalent in area. This little triangle here could be translated up to, could be actually rotated up to this one, right? And then this triangle here could be rotated up to this one, right? It's kind of like you fold it in and it makes a rectangle. One measurement was the height and the other was the average of the bases. So I like to write my formula as such. The area of a trapezoid equals
the average of the bases times the height.
Okay? And remember, the average of the bases is also the length of the mid-segment. If I wanted to write this in a more formulaic way, I would say the average of the bases is B1 plus B2 divided by 2, and then I would multiply that times H. What you want to do is choose the one that makes sense to you, right? In my case, this makes much more sense, right? Because I'm taking half of the sum of the bases, right? That's my average times the height.
Let's find the area of this. So in this case, the area equals not half of anything, it's a rectangle, right? The half comes from the average. So this base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, 27 plus 13 is 40, divided by 2 is 20. So the average of my bases is 20. Everybody see where I got that? That's the length of the mid-segment, 20, right? And that's a one-dimensional unit, and I'm going to multiply it by my height, 1, 2, 3, 4, 5, 6, which is also a one-dimensional unit. And that gives me an area for this trapezoid of 120 units squared.
Quadrilateral. Area of rhombuses and kites. Okay, and I put these together for a special reason because they share a property regarding their diagonals. Perpendicular. And why is that important? Because we can do the right thing. So here's a rhombus. And notice that a rhombus does not have, this rhombus has no right angles. Because of this property, that the diagonals of a rhombus are perpendicular, we can do the right thing just by using our diagonals. So notice, if I call this diagonal D1, and I call the other diagonal D2, that gives me a rectangle that circumscribes my rhombus. This rectangle is twice the area of my rhombus. In order to find the area of this rhombus, I can simply multiply my diagonals, and then take half of that. So if I have my diagonals, this is a very quick and easy way to find the area of a rhombus. But what's important about the kite is that it has diagonals, which are perpendicular and allow us to do the right thing. Therefore, I can use the same formula, diagonal 1 times diagonal 2, which gives me the area of this rectangle, and then I can divide that by 2 or take 1/2 to get the final area.
The area of my rhombus is diagonal 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 1/2 times 10. Diagonal 2 is 4. Half of 10 is 5 times 4 is 20 units squared. Times the other diagonal, which is 4. Half of 4 is 2 times 13 is 26 units squared. Okay,
So guys, please, do the right thing.
Do the right thing.